Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Hatim Yusofian. So I will present about introduction of implementing the MIPS. The MIPS microprocessor without interlock pipeline stage architecture is a reduced instruction set computer RISC architecture that has been widely used in various applications, ranging from embedded system to high performance computing. So in this context, MIPS is a type of microprocessor architecture. MIPS processors are widely used in various applications, including embedded system, networking device, and consumer electronics. MIPS architecture is known for its simplicity and efficiency, and making it suitable for a range of devices where power consumption and performance are important factors. So the project goals are to go over the fundamental of pipelining and the MIPS pipeline implementation. It is necessary to divide the execution of instruction into distinct tasks in order to implement the concept of instruction execution in pipeline. So my part, I need to create SR lash. Before I explain in detail, I will overview the SR lash. The SR lash is composed of two cross-couple NOR gates or two cross-couple NAND gates, and it is commonly used for memory storage and sequential logic. This project will use NOR gate because it is not too complicated compared to NAND. So as you can see, the figure below, we use the NOR gate, which is has two cross-couple NAND gates. So the value of SR uh, S0011 and R0101. So after that, we do the coding at a specific website. Then it will show the output of wave uh, in figure that I have attached. Next, I will explain about register. What is register? Register data types are used as variable in procedural blocks. They store logic values, only no logic string. The Verilog define the following register types. A register the unsigned variable of any bit size. The code demonstrates the basic concept of a MIPS processor register in Verilog. The test bench drives the register with some test, data, and clock, and the register file update its memory based on the input. So as you can see, the Verilog code to show the EP wave as a figure that I have attached in the slide.
Assalamualaikum and a very good day. So today I will present about the ALU, which is arithmetic logic unit. So what is arithmetic logic unit? It's basically a digital circuit that will perform logic and arithmetic operation on binary numbers. So ALU is a very important component in the CPU of a computer, and it also responsible on carrying out basic arithmetic operations such as addition, subtraction, multiplication, and many more. So as you can see on the slide, you can see the coding for the design and test bench, which is the Verilog, and it create an wave, as you can see on the slide. Next one is create state element on datapad. So what is creating a state element on datapad? So state element are used to store information that represents the current condition or state of the system. So this information could include things like the contents of register, the status of certain flags of or control signal, and other relevant data that if affects the operation of the system. So basically, the coding for the creating state element, as you can see on the coding on Verilog, which is the design and also the data bench, and which the table bench create a wave, which is the EP wave, as you can see on the slide.
Next, we'll explain about data memory. Creating a data memory in computer architecture is a critical process centered around developing a component that efficiently stores and retrieves data for the central processing unit, which is a CPU, during program execution. This involves defining the specific requirements such as storage capacity and access speed based on intended use of the memory. As you can see in the dialog section, this is the coding for create data memory need, and the result is EP wave below this. Okay, next I will explain about create sign extension. Okay, sign extension is a process used to expand the bit width of a binary number while preserving its signness. The process involves replicating the sign bit, which is the most significant bit of the original value, to fill the additional bit. For example, a 4-bit signed binary number 1101 with the leftmost bit as the sign bit. Sign extension to 8-bit would result in 11111101. This ensures that the signness of the number remains the same when the bit width is increased. Okay, the coding for the Verilog is above, as you can see, and the result is wave below that. That's all from me. Thank you.
My name is Muhammad Ikmal and I will explain about marks. In digital circuit design and programming, if efficient combines multiple input signal into one output, which is crucial in electronic and telecommunication. Marks help in data transmission by selecting specific inputs, which is useful in both circuit and software design. Mastering maths creation is a valuable skill for students, programmers, and engineers, offering diverse possibilities in technology. Executing the Mips data part is crucial in computer architecture. Revealing how instructions flow through a Mips processor. Mips know for simplicity is a key in computer engineering education. This overview explores executing the Mips data part, including stage and component. Whether a student or a professional in processor design, mastering the skill provides insight into hardware-level computer operation.
Okay. Lastly is the conclusion. In summary, MIPS enduring success stems from its adherence to reduce instruction set computing REC principles, featuring a fixed instruction format, ample general purpose register, and a load or store architecture for streamlined execution. The versatile instruction set, scalability across device, and the its application pattern interface, which is API, contribute to its popularity in industries like telecommunication and consumer electronics. Mips' commitment to execution efficiency is evident in its pipelining fundamental and complex fetch-execute cycle, complemented by consideration for the pipeline and charge. Furthermore, the discussion on SR latches emphasizes their role as foundational component in digital circuit design, showcasing MIPS reliability and efficiency. Overall, MIPS success lies in its thoughtful design, adaptability, and seamless integration of hardware and software. That's all.